Good morning. Solid Mensuration Book by Ashland Incorporated, 1951. This is the preface of the book. How about the dedication of the Massachusetts Institute of Technology? The acknowledgement by Mr. Vincent Asibuche, Shane Lingao, Victoria Mangiat, James Marasigan, and Mr. Jerry Palo. Contents. These are the table of formulas for plane figures, areas, station, and line values. Table of formulas for solid figures. These are the lectures. Solid mensuration with its general definition and properties, lines, planes, angles, and some mathematical trivias. Surface areas of solid figures. Solid mensuration for volumes of solid figures. Some example problems. After all the sample problems that the book had, we also provide sets of exercises that will enhance the user's capability in solving, especially in solid mensuration problems. For multiple choices, solid mensuration, father of geometry, I think it is Euclid. Let's try this one. Branch of geometry that deals with point, line, and surfaces, solid mensuration. Next. 6 matching surface sides, cube. Distance from the centers to the same, sphere. Tapers from a circular or roughly circular to a base point, I think it's cone. Also called a rectangular or solid, rectangular prism. Let's make it true, I'm not sure. And then this one is false. Science, which treats of the properties geometry. And then thickness but that has no position point. In this portion, if it is 1, it means that your answer is correct. And if it is 0, that means your answer is wrong. But before you submit all the correct answers, you are going to press the done for the counting of the correct answers. Done and then submit. So this is the results. The correct answers, and then the score, also the percentage. The percentage varies upon the score. Let's try these two options, the electronic calculator and conversion calculator. Electronic calculator deals with a calculator that is electronically devised intacted with the mathematics laboratory or MATLAB, and then it is encoded to its different purpose for different types of shapes, solid shapes that we choose. This results GUI offers 2 different buttons for the electronic calculator and for the conversion calculator. First, we're going to try this electronic calculator. Let's try this one. Solid mensuration electronic calculator. We have here 5 different solid shapes: the cone, cube, rectangular prism, cylinder, and for the sphere. And most especially, each shapes offers 2 different choices. First is the surface area, and the other one is the volume. Later on, we're going to try both of the 2 and then restore all the values that we computed. So let's try this first. The surface area for the cone. Surface area for the cone. Let's try this height. Later on, we are going to try this one, slant height. We're going to put the radius for 1, and then the height is 2. Solve. The answer is 10.1664, and then store the values. If you want to recalculate it, you can press clear, and then if you don't want, go back to the first play, home, and then next, volume of the surface, volume of the cone. Put the radius 1 again, and then 2, slant height, height only. Solve the answer. How about for the cube? Let's try this one. Surface area is equals to 3. Then solve 54. Store the values again. Clear. Nor whatsoever. Home. Last one for cube. The volume. Let's put again 3. 27 is the answer. Store values. Press home. Surface area. Length 2, How about 4 and then the height is 5? Solve, then store the values. As we see, the values that we are going to input in this part, the option or the output will be indicated also in the volume part or in the figure, in which indication by the place that the length, the width, or the height should be placed on. Store the values. Home, let's try volume. For the length, volume of 3, width is 4, and the height is 2. 24. Again, store the values. For the cylinder, surface area, we have 4, and then the height is 3. 175.929. Again and again. 12. Going back. The volume, the radius is 3.4. Height, we have 7. Let's solve this one. 254.218. Store the values first, and then home. Surface area, the radius is 2. Solve this one. 50.2655. Store the values, and then home. Last one, the volume of the surface area of the sphere, or the volume of the sphere. Put the radius 3.4. Solve, and then the answer is 164.636. Again, store the values, clear, or if you want to go back home, most especially the exit if you want to close this all in all. And then, but before that, let's recalculate all the things that we put into the storage of this MIDI calculator. So let's try this one. So going back, all the details that we input on the storage a while ago, we're going to calculate the results for the addition or different operations that we have here. So let's calculate the results. On this pane, results calculator, there are 10 different choices from the left and from the right. For cone, cylinder, cube, rectangle, prism, and sphere. And then what we are going to choose is the values that we want to add, subtract, multiply, and divide. Let's try this one. The volume of a cube that we get a while ago, and the sphere, surface area. If you want to add 77.26, 27 plus 50, 77.26, subtract, multiply, and divide. That's it. For the sphere, rectangular prism, cone, cube, cone, this part also, the answers varied upon the subtraction, multiplication, or the operation that we choose, and varied upon the values that we have from the past. So that's all. We're going back there. And yes, for the last feature of this project, the conversion calculator. Conversion calculator is not different with the other conversion calculator, with the other conversion table. What we're going to do is just to input here values that you want to convert to another unit of values. For example, in terms of length, 45. Meter to millimeter, 4,000, 45,000. Meter to centimeter, and so on and so forth. There are many choices here. And for the volume, 35 milliliter to liter, it's 34,000 liter. That's the only purpose of the conversion calculator. If you're asking why we put conversion calculator in this portion, because if somehow, some portion of the moment, when the user wants to convert the values, before he or she use the electronic calculator, it is easy because it is also compacted here in our codes. So once again, this is our solid mensuration electronic calculator. In one book only, electronic books. So you better choose this one, sir. Once again, this is the magical book of solid mensuration by yours truly, Lauren Manguiat, Vincent Asibuche, Joshua Marasigan, Jeremiah Palo, and Ira Shane P. Lingao. Thank you very much. So yes, all in all, in this whole project, we have here a total of 27 graphical user interface or GUI. Starting from here to there. Before we proceed to the final GUI presentation of our project, let us first discuss the codes that we used. From GUI 1 to up to 12, we only use single page code. For example, this one. For number 1, this is very basic because the GUI means is already an image. We first edited on the Photoshop and then after put it inside the mathematical laboratory, the MATLAB, as what you are seeing here. Handles output is equals to object, access handle access 1, image show 1.jpg. So basically what you're going to do is just to imagine how many images that you're going to put inside the GUI and then code it in this portion. And then make sure that your tags are well distributed and you're not going to confuse on what tags that you're going to use. That is for number 1 to number 12. The preface, the first portion of the electronic books that we have. So that's for the first phase. Next, after that first part of the electronic book is the alternative or the exercise. This is just a simple thing because we are just use switch loop cases for each of the for each sets of questions, and those cases corresponds to different correct answers. We set it Q6, for example, Q6 is equals to 0 or Q6 is equals to 1 when the answer on that particular push button, radio button is correct. Later, we are going to try the codes as basically if the answer is correct, 1. If the answer is wrong, 0. The text pane. We're just going to show it inside the text bar. We have 10 questions there, 10 different sets of questions, and switch cases. This part, global 1 to 10, is to indicate that the values on that particular loads of areas is going to use in another GUI. The values that we stored in global 1, in global Q1, string to double, which means that the values on number get handles that txt to 1, the place where this portion is going to get, and then string, which means to show it on the basic part of letters or numbers. And then this is for 1 to 10. Then to compute the result is Q1, Q10, just add all in all. Set handles. We use this one set because we are going to set the values that we get from the first global. Handles that tbres. This tbres is the place where you want to set or to show the values that we get from the first global. String and then result. That's all. That's the first part. And then after this one, result or the final score tally, final score tally from the quiz or from the exercises will be up here in the output. So as we notice, global 1 to global 10 is still up here because what are the values we are going to use from the result and percentage we're going to get there from the first global that we put into the alternative GUI. And then another set handles txt per our location is string and percent. This percent indicates the calculations that our codes is going to pursue. This percent, as we see, percent is equals to results over 10 times 50 plus 50, the engineering scoring basis here at our school. So that's all in all. Basically, this is the main part of our project. The calculator, electronic calculator for different solid figures in the solid mensuration. Cone, tube, sphere, cylinder, and the rectangular prism. So this is the GUI that shows all of those 5 images and all of those 5 functions that we have. it is linked into different GUI. GUI linking is used, or specifically this is measured into the callback of the push buttons that you choose. For the first, we have cube, surface area. This is the surface area of the cube. This is the computation, global one, which means the value of x1 is going to use to another values, another GUI. Cube, volume, cylinder, surface area, cylinder volume, and then so on and so forth. So as we notice, those 5 different shapes, we use 5 different formulas. Not just 5, but 10 all in all, because we have surface area and volume. For us to easily make those codes, we first write all the formulas basically on a sheet of paper and then try to recalculate it on our own. And then after, we are going to put it inside this coding system, depending on the callback that you use, on how or on when the system will going to compute the answer. For example, in this part, we put the computation basically for the cylinder volume in this callback, the CYVSOL callback. We put this the global one, the global 2, and then the equation for that particular formula. Why we do that? Because the computation will no longer be okay until that particular push button is not hit by the user. So, at the time that the user pushes that particular button, that is the only time when the system will compute the result of the input you want to compute. So that's the only thing we had for this 10 different calculator. That is very basic.